All right, good morning, good afternoon, good evening, ladies and gentlemen. Welcome to this series of online lessons. If you haven't already, subscribe to the channel, leave a like, comment, and share. Now, in today's video, we are with Mufulira College of Education in association with Chadimbana University, and we're just going to look at some Taylor series problems. So I have marked out the questions that we're going to look at. So the first one says find the Maclaurin series expansion of f of z equals to z squared over 1 plus z. So a Maclaurin series is just a special Taylor series. I'll explain that in a moment. Then the other one says let f be this. Express f of z in partial fractions, hence find the Taylor series of f of z about z equals to -1. All right. So we'll start with the first one. Find the Maclaurin series expansion of f of z equals to z squared over 1 plus z. Now, remember I said a Maclaurin series is just a special form of a Taylor series. But what is a Taylor series? Well, a Taylor series is just a series of the form f of z, okay, f of z equal to the sum from 0 to infinity of some constant an, then z minus z naught to the power n, okay, where an is equals to the derivative of fn times at the center z naught over n factorial. Okay, so meaning that when you just find the derivative of fn times, you replace there the general form, and z naught is the center of the Taylor series, and that is it. Okay, and the expansion simply becomes a naught when n is 0 to be n naught. This to the power 0 is 1, so it will just be 1, plus when n is 1 we're going to have a1, then this to the power 1 z minus z naught, plus a2 z minus z naught to the power 2, plus, and so on and so forth. Okay, so this is a Taylor series. A Taylor series. All right. Now, what is a Maclaurin series? A Maclaurin series is just a Taylor series where z naught is equals to 0. Okay, so in a Taylor series, z naught is equal to some constant. It can be any number, it can be complex, it can be real, it can be whatever. So it is some constant c. This can be 1, 2, -2, whatever number you can think of, even 0, because we just said a Taylor series is just some special Maclaurin series. So, but when you're told to find the Maclaurin series, what they're just saying is that this Taylor series is centered at z naught equal to 0, and the series should look somewhat of the form z naught, or f of z equals to sum from n equals to 0 to infinity of an. Then now where there is z naught here, we'll put 0, so z minus 0 is just z, so just be z to the power n, like that. And the expansion of this, when n is 0, you're going to have a naught, plus when n is 1, you're going to have a1z. When n is 2, you're going to have a2z2 plus a3z3 plus, and so on and so forth. So this is what a Maclaurin series is. And generally, the longer process of solving a Maclaurin series or a Taylor series requires you to find these constants here. When you find all these constants, you replace them there, then you're good to go. And how you find these constants is by differentiating f several times. But in this tutorial, I'm just going to show you a simple method to work around this. Okay, so remember our given function f of z is equal to z squared all over 1 plus z. Okay, now whenever you're given a function that has a quotient like this, okay, a quotient is some sum of z, okay, you can easily manipulate it to find the sum that looks like this, okay, because you know of a sum that looks like this, and this sum is known as a geometric series, okay. So we know that the sum from 0 to infinity of z to the power n, this is a geometric series, okay. This is equals to 1 over 1 minus z if and only if the modulus of z is less than 1. Okay, so this is a if and only if. So you know this, okay. So what this entails is that when you have z here, you can simply replace z there, but here you should have 1 and here you should have minus. That's the only condition. And the modulus of z should be less than 1. And that's it. Now, this just looks like this if you see closely. It just looks like this, where now the coefficient here is just 1. Okay? And you have that. So easy does it. Now, you can also manipulate this to be centered at some form. Okay, for instance, if we have summation, or let me start with 1 over 1 minus, if this was centered at z minus c, some constant, this would be equals to the sum from 0 to infinity, where there is z here, which is this z here, they should be the same, so it will just be z minus c to the power n, and this will be a Taylor series with some constant c. And if c is equals to 0, we'll go back to this part here. Okay, so basically the goal here will just be manipulating the given function into the sum, into the convergence of a geometric series, and we'll estimate the sum of the geometric part. All right, so, and we are done. So that's the easy way. So for our given function f of z, which is equals to z squared over 1 plus z, this is composite because we have more like two functions. We have the numerator and the denominator. So if we want this form here, where we have 1 over some numbers down here, we can simply factor out the z squared. So we can write it as z squared, then 1 over 1 plus z. And this is general for all functions. You can factor out a particular part of a function, then you expand the general form of the Taylor series, then you multiply the factored function back after you do that. So you can do that for all functions that are composite. All right, so what we just need to do is we need to find the Taylor series or the Maclaurin series of this part, then later we multiply by this part. So that is for composite functions, the functions that can be factored out. Okay, so we'll do that. So we'll just find this. So we need to manipulate this to be of the form 1 over 1 minus z, because we know that if it's of the form 1 over 1 minus z, this is just equals to the sum from 0 to infinity of z to the power n, where this z is this z, but here there should be a minus and here there should be a 1. Okay, so this is, you know, this even, it's the same as the geometric series in grade 12 class. So it's just the same. So how can we manipulate this to look like this? What we just need is a minus here. We already have a 1 here, so no big deal for us. But if there was some other number here, we would have factored it out, as you will see in the next example. But here we already have a 1, so checks out. But here we need a positive. We need a negative here. We have a positive, we need a negative. How can we do that? Well, we can write this as z squared, open brackets, 1 over 1 minus, now we've introduced a negative, so we'll need another negative, so that when we multiply negative and negative, we get positive, and we have z like that. Okay, now this now looks like this. Okay, so this part is representing the z here. We have a minus, which is this minus. We have a 1, which is this 1. So meaning that we can rewrite this as equal to z squared, open brackets. So the z, whatever z is here, excluding the minus here, you write it here. Okay, so in this case we have the sum from 0 to infinity. Our z in this case is negative z, so we say negative z raised to the power n, like that, and you're done. So whatever you have in the brackets here, you replace them inside here on z, and you raise everything to the power n, and you're almost done. So from here, what we'll just do now is expanding. Okay, but before we expand, we can simplify so that the expansion is easier. So we can write this as z to the power 2, open brackets, or I can just write it as sum from 0 to infinity. So this, we can separate it as negative 1 to the power n times z to the power n. Because this is the same thing as negative 1 times z, then everything raised to the power n. And using the index rules, we know that the n distributes to both the z and the negative 1. Okay, so we have that. We can now take this inside by multiplying it to this part. So it will just be equal to the sum from 0 to infinity of negative 1 times z to the power n times z to the power 2. Okay, now since we have the same bases, the powers can sum, so this is sum from 0 to infinity of negative 1 to the power n, then z to the power n plus 2. Now they ask for the expansion, so to expand that, we'll just start substituting values for n equals to 0, n equals to 1, n equals to 2, n equals to 3, and so on and so forth. So this is plus 2, sorry for that. So when n is equals to 0, we have negative 1 to the power 0, which is positive 1, then z to the power 0 plus 2, which is z to the power 2, plus, when n is equals to 1, we're going to have negative 1 to the power 1, which is negative, so here we're going to have negative, then z to the power 1 plus 3, it will be z to the, 1 plus 2, it will be z to the power 3. When n is 2, so negative 1 to the power 2, that is positive, so we put in positive here, then z to the power 2 plus 2, that's 4. Then when n is 3, we put in negative 1 to the power 3 here, it will be negative. Okay, then z to the power 3 plus 2, that will be z to the power 5. And we continue this, and so on and so forth. So this will be the expansion. Okay, so you're done with the first question for the Maclaurin series expansion. Okay, easy does it. So whenever you see a quotient like this, you can use this method. Always just try to separate the part that has that looks like the sum, the convergence of the sum of the geometric series, and the part that looks like can be factored out. Otherwise, in most cases, they'll just give you some simple questions. And if it was, let's say, if it was f of z equals to, let's say it was 1 over z plus z squared, you could also factor this out as 1 over z, then we have 1 over 1 plus z, like that. Then you could simplify. So just look for ways to factor out so that you can relate it to the geometric series. Okay, let's look at the other example here. Okay, so let f of z equals to z over z to the power 2 minus 1. Express f of z as a partial fraction. Okay, so f of z as a partial fraction. First, notice that this is a difference of two squares, so we can write this as z over z plus 1 times z minus 1. Okay, and we want to write this in the form a over z plus 1. So this is minus 1 plus b over z minus 1. Okay, so that is what we do. We just equate these parts. We just need to find a and b, and we're good to go. So what we do is just say z over z plus 1 times z minus 1 should be equal to a over z minus z plus 1, doesn't really matter the order, plus b over z minus 1. So we can multiply throughout by this. So we'll have z plus 1 times z minus 1. So we see that on this side, we're just going to have z being equal to this z plus 1 will cancel with the z plus 1. So we have a times z minus 1 plus the b. This and this will cancel out. So you're just going to have z plus 1. Okay. And for this, you just need to look for values of z that would eliminate a and value of z that will eliminate b. So in this case, we want to eliminate b for instance. What number can we put in this equation to eliminate b for this part, this entire part to be 0? This entire part will be 0 if this is -1, because -1 plus 1 will give us 0. Okay, so we'll let z equals to -1. So we'll put -1 everywhere. So this will be -1 will be equals to a. Here it will be -1 minus 1 plus b, -1 plus 1. This will be 0. So we'll just remain with -2a equals to -1, meaning that a should be equals to 1 over 2. Okay, we'll do the same. We want to get rid of a so that we remain with b alone. So a can be gotten rid of if this is 1, because 1 minus 1 will be 0, meaning that it will eliminate a. So we'll let z equals to 1 and would have 1 equals to, so this part will be 0. Let me just write it. So a open brackets 1 minus 1 plus b 1 plus 1. Okay, so this will have 1 equals to b 2b, meaning that b is equals to 1 over 2. Then replacing back, we have f of z, which is equals to a over z plus 1 plus b over z minus 1. Okay, so you need to confirm that is correct. Then, yeah, it is correct. Then we just replace. So this is this can also be written as 1 then times b here times a because of the fraction, like that. So we can write this as a, which is -1 over 2, -1 over 2 times 1 over z plus 1. Okay, or I can write it as 1 plus z, and same applies here, plus 1 over 2. The b part can be written as 1 over, I would write it as, I can factor out the negative down here so that I write it as 1 minus z. Okay, so there's a reason I'm doing this. So finally, let me put it here. So it will be negative 1 over 2, 1 over 1 plus z minus 1 over 2. So since we've factored out the negative here, so that we have 1 minus z, so we have 1 over 1 minus z, like this. Okay, so something like this. Now you can see already why I am doing this, because the second question asks us to find the Taylor series about this point. Okay, so it will follow the same procedure. So Taylor series, so now we have our Taylor series, f of z equals to this. So Taylor series about z naught equals to -1. We need to manipulate these so that here we have z minus 1 here, and here we have z minus 1, but without changing the form of the question. Okay, so how are we going to do that? So it would be easy, just some algebra. F of z would be equals to -1 over 2 over 1 over, so we need so we have 1 plus, we need a z minus. Okay, so now here you need to be careful now. Okay, you need to be very careful. I just remembered something. Remember, a Taylor series is of the form f of z equals to summation from 0 to infinity of an. Then you have some z minus z naught. Okay, so now in our case, the z naught is negative. Okay, the z naught is negative, so meaning that here it will be negative, then -1. Okay, so meaning that here they should be positive. It will be just z plus 1. So we are looking something of that form. So here I'll put plus 1. Now, I don't want to change the meaning of the question. If I have z plus 1, what can I do to get rid of this 1? I can subtract 1 outside here. Okay, and this will say z plus 1 minus 1 will get rid of the 1, and we are good to go. So this is for this part. Plus the other part, we have -1 over 2 as well. So here we have 1 over 1 minus, again here where there is z, we want z plus 1. Okay, we want z plus 1, and the idea is not to change the meaning of the question. So but we see that we have negative z, then -1. What will get rid of this -1 is a positive 1. So let me just say I've added a plus 1. So this times this, it will be -z, which is what we have. So negative times +1, it will be -1. So we don't have -1 in the original equation, so we need to get rid of it by introducing a +1. Something like that. Then we can simplify everything. So our f of z will be equal to -1 over 2, open brackets. We see that this -1 and this, they will simplify to 0. So we just have 1 over z plus 1, which we can write as 1 plus z. Okay, like that. Okay. Then we have here we have -1 over 2. So these will add, so it will be more like 1 over 2 minus z plus 1, like that. Okay, so now here now we have our center. Okay, we have our center. This whole thing is representing z, this whole thing is representing z. Okay, then when you compare this to the geometric series, we have 1 over 1 minus z, okay, should be equals to the sum from 0 to infinity of z to the power n. Okay, so now here we are not going to touch anything because it's already in 1 plus z, which is what we are looking for. Okay, I can write it as z plus 1 anyway. I can write it as z plus 1, which is what we are looking for. Remember here we said the center is z plus 1. Okay, so which is what we are looking for. But here we need to factor out a 2 so that we remain with a 1 here. So already there is a minus and the minus, so there is no problem. So what we just need is to factor out the 2. So we have f of z will be equal to, so this will remain as it is, negative 1 over 2 times 1 over z plus 1 minus, here we'll factor out the 2, so we're 1 over 2 times 1 over 2, this 1 over 2 will be factored out, then here we'll remain with 1 over 1 minus, since we factored out the 2, we don't want to change the meaning of the question, so we need to divide by 2 plus 1 over 2. Okay, like this. So now we can now manipulate this part because we know that this is of the form that we are looking for. So this part, this whole lot of this part is representing z. So we'll replace this whole lot of this part here. Okay, so our f will finally be, f of z will be equal to negative 1 over 2, 1 over z plus 1. Then this can be written as 1 over 4, open brackets. This, we're going to have the sum from 0 to infinity. Then this part is z, all out of it, so it is z plus 1 over 2 raised to the power n, like that. So you get all out of this. So this part is simply this part, and you replace all of it there, you raise to the power n, and you're done. Okay, and obviously you can simplify. You can write this as f of z equal to negative 1 over let's say negative, all right, that's negative 1 over 2 z plus 1 minus, this can be written as okay, I was right, as 1 over 4. Then here we have the sum from 0 to infinity. We can break this part into two parts. We need the z plus 1 there to the power n over 2 to the power n. Okay, so this 4 can be brought inside as 1 over 4, the way it is. Okay, and we can further simplify this because we know that 4 is just 2 to the power 2. Okay, so 2 to the power 2 times 2 to the power n, the powers will add, will give us 2 to the power 2 plus n, something like that. Okay, so the idea is to simplify as much as possible. So z equals to negative 1 over 2 z plus 1 minus the sum from 0 to infinity. So this and this will add, so we're going to have z plus 1 to the power n all over 2 to the power 2 plus n. Okay, so now if you're asked for the expansion, you need to expand, but if you just ask for the Taylor series, you just leave it here. But if you're asked for the expansion, you now replace in the values. Expansion, you replace in the values of n from 0 up to n. So you have negative 1 over 2 open brackets z plus 1 here, which is fine, minus, so this part when n is 0, Okay, this part will be z plus 1 to the power 0, which is 1. Then this part will just be 1 over 2 to the power 2. Okay, plus when n is 1, so this will just be z plus 1 to the power 1 over 2 to the power 3, like that, plus when n is 2, we're going to have z plus 1 to the power 2 all over 2 to the power 4, and so on and so forth. Okay, which you can further write as f of z equals to negative 1 over 2z plus 1 minus, this can be written as 1 over 4 minus z plus 1 over 8 minus of z plus 1 to the power 2 over 16, and so on and so forth. All right, so this will be the Taylor series expansion. You can go through the video over and over again. I'm also going to share this PDF so that you can just look at the problems as you are following through. Have a great day. I hope to do more examples for you.